Hi and welcome. We're back to the Weld box project again. I have to make like 6 or 7 more of these after we finally get this design locked down. So last time we built new parts and hardened them that would allow a lot more access to the inside here, and that worked out pretty well. One thing I didn't do was I didn't allow any relief post-weld. So what happens is right now the laser sits over here on this side of the welder and welds the pocket. So as the material warps because of the welding, they use 304 stainless, I believe. 400 stainless has about half the expansion coefficient of expansion is 304, but it's too expensive to use. So they're getting quite a bit of warpage, which causes the part to get locked up inside. Not so much the weld box, because there's only a little bit of material here, a little bit in the weld box, but then there's a bunch of rollers that it picks up on that get tighter as it starts to push down. For one thing, it warps like this. So this box is holding the part in place, and then those rollers are fixed in space, and the part really wants to curve down when it leaves, but it can't because of those rollers, which pushes up on this box, which causes the whole thing to bind up. But on top of that, this is the wire feeder. They haven't used wire feed yet, but they want to use wire feed to add some additional material rather than just melt the material at the weld joint. So this wire feeder fits here, and as you see, it's still where the laser position is fine. However, in addition, as you're adding the wire, you're going to see material blow all over the place. And as you can see how dirty this box is, even without adding wire, there's a bunch of extra material inside here. So we want to add an air blast that blows stuff away. Well, that means that this laser can no longer be sitting over here in this pocket. It needs to be closer to center. And as a result, what we need to do is we need to make a holder that'll hold this air blast, first of all. But second of all, the laser has to be biased out. And on top of that, I think having this much of the parts engage the material post-weld is going to be a problem. It's going to bind up. They had to make it a little bit looser than we wanted to begin with because of that binding issue. So I'm going to take all these parts out and relieve them from the midline over so that they don't actually come in contact with weld, because there's actually no reason to guide the material other than extremely loosely past that point, because the rollers after this box will pick that up. So that is what we got to do. We got to take all these out and surface grind them, because I don't think I can hard mill them. They're like Rockwell C58 to 62 kind of thing. And I think that'd be probably a bit challenging. So we got to take off some material there. And then I got to make a new bracket. And because we're not quite sure how this bracket's going to ultimately function, I think what I'll do is I'll 3D print it. Because there's no force on this. It's literally just holding these parts in place. There'll be a little bit of force as the wire pushes through this, but almost none. So I don't think that's a big deal. I'll initially 3D print it so we can test the idea. And then if they like it, we will make one out of metal, because starting with metal I think will be a problem. And then they have to make a shim that's going to bias this laser, because this laser actually has no axial control in this axis right here at all. It can go up and down, and it can go in and out, but it can't go this way. There's no control. That's set by the fixture itself that holds the laser. It's actually just the head of the laser where the fiber laser terminates. And so as a result, we need to they need to make a shim that's going to push the whole laser assembly out where the fiber terminates. By the way, this whole tube, the point of this tube here, they actually currently do put gas down the center of this tube to keep debris from blowing in, but it's not quite enough. They still lose the lens that's located, somewhere around here, and that's quite a bit of depth. So the debris makes it up here, and if it gets on the lens and the laser hits that debris, then it creates a hot spot and destroys the lens. And they've gone through quite a few lenses. So yeah, there's a lot we need to do here, and so we're just going to give it a shot. We're going to make a 3D printed fixture for this, and we're going to surface grind all these guys. I don't know if you can see this, but there is a ton of gunk in here. I don't know how well that shows up. And this is only from doing, a couple dozen feet, maybe 50, 100 feet of material through here. And so I have a little bit of issue with the idea of blowing this direction, because it might very well, and there's going to be one of these on each side ultimately. Right now there's just one on one side, but there's 2 lasers actually. So there's a laser on this side and there's a laser on this side, and it welds both sides of the part simultaneously. And I think you know, blowing all that debris upstream to where you're going to weld might cause a problem. I don't know if it's a good idea. I tried to convince them to do something like coaxial around this that would blow air around that, which would also cool the tip. They weren't so interested in that, but I think blowing this debris upstream is going to cause it to accumulate in the fixture, and that's going to be a problem. So we'll find out. All right, first step is to get these guys out of here. So I got to take this whole fixture apart again, and then I got to remove and clean all of these before we surface grind them. You can see the amount of soot on here, tons and tons of soot, which probably includes some hexavalent chromium compounds, since we're doing stainless steel. So probably make sure you wash your hands really well after dealing with any of this stuff. So we're just going to disassemble this guy again. You've already seen this a bunch of times, so I'll probably fast forward through this whole part. More evidence to make me a little bit concerned. You can see the soot. So the welding is taking place, I believe. Let's see if I can get this right. I believe the welding's taking place over here. You can see the massive soot accumulation, including the laser blowing through and hitting the base, interestingly enough. Wherever the laser is going to be, we need to relieve the material even a little before it, so that the laser will be out of focus and less power will be, so we won't damage this surface here, even though it shouldn't touch it then. That's right, we added a shim under the center to match the height of the rollers, the incoming rollers. Got to remember to put that back. All right, so you can see which parts need to be ground now. So I'm going to get a Sharpie and just mark where I want to grind. Basically, this whole inside face where you can see it's been contacting the material, there's a lot of light scratching going on. Thank God we made this hard material. It didn't wear like the old ones, which is very good. So all of this. All of this. This guy will have to be done by itself, but it's all of this. And then this one, you can even see where it rubs here. I don't know if you're catching this in the light, but you can see where it's rubbing. And we just need to remove this. Like on this one, same thing. So we have all the parts lined up here. We can take off material on them equally. This is the base piece that everything slides on that we shimmed up 10 thousandths. This one from the midline, I don't know if you can see that faint scratch I put in here. We're going to surface grind all these guys down. I technically only need this little spot here, so if I was going to do it again, before I heat treated it, I would remove the material here. But now I've got to do it the hard way. So we're going to surface grind all these guys down up to this midline here. And hopefully as the material curves down or curves over to one side or the other, because not all of these parts are symmetrical. The T-stock that this particular weld box is for is symmetrical, so it tends to come out fairly straight. But some of them, the part is shifted over, and then when it shrinks, it's no longer, it wants to curve one way or the other depending on which side it's closer to. So that'll be a problem. It'll be more of a factor in the future getting these side pieces here, but we're going to do it anyways because there really isn't any reason to hold the part in line much after it's been, what am I trying to say? After it's been welded. So, all right, I'm not going to show you the grinding. It's going to be very straightforward and not super exciting, and I'll bring you back. All right, so we've relieved all the parts. We can reassemble this guy. You can see here, I only needed the top section of this where it's rubbing. You can see right there the mark, but we did the whole thing because I couldn't easily hard mill this. Rockwell 62 was likely going to make this a very challenging operation. Okay, next is this guy. We relieved the post-weld side of it. Made to get the shim in there. There's the shim underneath, so we're good. We did number these 1, 2, 3 with the laser engraver in case you forgot. So this is one bottom, so this one will ultimately be here. And I made all these things fit so closely. So this one's one bottom. This is 3 top, so this one's the one that goes over here. So it'll mount right there. This one is number 1 top. This one will sit on top of that one. So let's start this one. This is the one where they didn't get their holes straight. So we'll put that one in first. There is this shim piece that we created to go in there. I forget which side. I think it went in this side right here. All right, so I got the shim in here. I'm pretty sure this is the side it went on. I can ask the guy I work with to verify that, but I'm pretty sure that's what it was because this side was sticking funny. So the next one that goes in is this guy. And I didn't touch any of the adjusters, so this should reposition where it started. And this guy goes here. So you can see the relief here. You can see the relief in both of these guys, which will line up with the relief on these here. So when we assemble this whole thing, now there should be a fair amount of relief underneath the whole thing. There we are. Alrighty, so now you can see that the exit side of this has a lot more space than the input side. The input side is the part that does the aligning. Probably should have thought of this to begin with. And it all starts right here halfway. All right, so now that we've finished the weld block, I need to build a bracket that's going to hold a second tube alongside the laser tube here. So my first design was going to be something like this, where this goes on the tube. This guy fits this tube right here, and this guy fits this tube right here with a couple set screws for each one of these. And I did this 3D print first because I could try out the designs quickly, because if I did this in metal, this would take a long time. And I forgot one fact, that I gave up this degree of freedom right here, which I think you need. So this one's toast. And there was one before that. And finally I settled on this design right here. And this will hold a tube on this side and press it against this base piece here, and a tube on this side, which is close enough that I had to relieve this section so that it could just rotate back and forth there. The top is designed for an 832. I need a metal plate that sticks out, has a protrusion with quarter inch diameter protrusion to be a rotating surface that will go part way up into this part here through there, and then tap for 832, and I think this might work. I just need to make some aluminum pieces that are threaded here to add the pressure, because I didn't want to thread this directly. I didn't think it'd be strong enough. Maybe it would be, but you know, considering this is a compression style thing, I just didn't want to risk it in plastic. With these guys, these two set screws here, that's not going to be a problem, because they just have to lightly press against this tube here, which you get to by unscrewing this guy right here. And then this guy comes off and I can put this guy on. Now these set screws are special. I don't know if you've seen them. You can see right in there. They're plastic tipped set screws, because I didn't want to damage the tube like the previous set screws they were using did, scoring the aluminum pretty heavily, because that seems undesirable. So I use plastic tipped ones. You could also get brass tipped ones, and they've got another variety, or this plastic I believe is nylon. So they call them nylon tipped. So we just need to make a couple aluminum parts real quick for these guys, to apply opposing pressure. And I actually need two complete assemblies like this, because there's two lasers working simultaneously. Then this part here, this piece of stainless steel tubing, I'm going to make a piece that goes on the end here that just has air holes that allow you to blow to the side. Because one of the other things is, you notice this is probably required, but the wire feed had to have a sweeping turn, which spaces it out from the laser. And what that ends up doing is requiring a ton of extra space in the weld box here. And that was why we originally modified these weld boxes. It goes this way, and now we've relieved them as well. But so that all that has to fit in here. So the tighter this can be up to next to this, the better we're going to be as far as being able to be in the center here. We also need to adapt the back of it to take a 1/4-inch hose in for this. Now, this may actually work out that I can just leave this in plastic. The question is how much heat will go up the wire feed tube. And I don't know that it should be so much, because the laser's not actually hitting the tip of the tube directly. It's just being exposed to the infrared radiation and probably some conductive heat. But when I add this air blast, it's going to actively cool it off. So I think we'll be cool all the way up here, and I won't have to worry about melting the plastic, and maybe I can just make this whole thing out of plastic for them. We will see what works and what they're happy with. But in the meantime, let's start with the aluminum, and then we'll work on the air piece, the air distribution piece for the end of this guy. First up, we're just going to face this part off. Take a high feed rate here. Doing a quick fit test, I realized I made this thicker the second time on my design. I hadn't compensated for that. So I need this to go back another 0.2 inches that way, so that the aluminum can stick proud there, because it's also going to mate with the bottom of the other part. All right. All right, let's see how we're doing with the test fit here. It's a good press fit, which I like. And have this guy stick on the end. Oh yeah. That's a little tight. I thought I was going to need a little more of this post protruding, because I hadn't actually designed this in CAD. I just sort of, well, I designed the 3D part in CAD, but not with these parts in place. That's actually going to be pretty good, I think. Going to drill for 832. I'm using alcohol as a cutting fluid here. Still need to make the air diffuser for this guy, but assembling these other parts just to show you the set screws I'm using to push against this instead of regular ones like the other design had. I'm using plastic tipped ones so they won't damage it. And it takes almost no force at all for this thing just to lock right down on it, so that's pretty handy. Then to add some strength, rather than thread into the plastic, for these pieces, I created aluminum posts that just push right in here. Okay, and then these guys, so all of these holes everywhere on this were a little bit undersized. I had them exactly on size in the software for like the proper tapping size screw, and it is actually much smaller than that. So what I ended up doing is using a reamer and reaming these out so they'd be the proper size. This guy here goes on here. This guy goes on here. This guy goes over here. And this guy goes over here. Then I buy these Allen wrenches at McMaster Car. They've got them in just about every size. These cost like $1 a piece, maybe, or less sometimes. So I tend to include them with the tools so that the customer doesn't have to look for a specific Allen wrench when they want to modify the tool. They can just keep the Allen wrench with the tool if it's something that I think they're going to have to modify. You know, they're going to want to play with adjustments on. So I've done that for them. I'm not going to screw these in all the way, because I still have to put in a couple of these guys here. These will mount on here. You just snug down this. Look, just light snug, just that much. And this thing's already really tight in there. The plastic's really perfect for that. So we're going to do that. And could insert this guy in here. I made those a little bit snugger than they probably need to be. It's a nice solid grip on there. This is a stop screw. I'm not sure what the intention was for putting this guy in here, but I guess it threads from both sides. That's pretty odd. That attaches to the rest of the wire feeder assembly. And then I've got to take this, this guy here, and we've got to make the diffuser that's going to attach on the end here that'll blow air or argon, neutral argon across this junction here. As for the back where it's going to attach to the hose, I'm going to cut this off because it's too long. But this is just quick connects, 1/4 inch both sides. You can just press it right on, fits perfectly. So it's a great fit. All right, here's the project completed. So the wires fed in from one side, the air blast is going across the other direction. Here's what the air blast piece looks like. This is my prototype, so if they don't like it, I can modify it. This is a 1/4 inch press fit into the brass piece here, and then I threw some epoxy on just for added measure. These things fit on the pipe perfectly, so they're great. I think they can use that for the air hose, no problem. And I made 2 of them because remember there are 2 lasers. So I think we're really good to go on this project. For the air hole size, I had 2mm PC board drills. That's what these hole sizes are. And what I did was I calculated the area of the inside of this tube here, and then made sure that the sum of the areas of these 5 holes was just a little bit under, so that way you'd have some back pressure, and I'd hope have a good stream. We'll test it out, see how it works. Well, this project advances to the next step. I'd like to say it's done, but I doubt it's done. It'll probably be iterated again. But for now, we're at a stopping point, so we can go test. Thanks for watching. Hope you find it useful. Hope to see you next time.